Hi, this is Brian Kim. I want to share with you case number 170 in the best way to do cataract surgery series. This is a 3 to 4 plus white cataract. You're going to see use of trypan blue, and you can do that even when you have smaller pupils. In this case, you're going to see double chop, cross chop, and this is also a panoptics case as well. And you're going to see the concept of lifting pieces up out of the bag safely and easily using the chopper. So the chopper is really the most versatile instrument when it comes to lens disassembly, in my opinion. And so I've noticed that just, people really underutilize the chopper for a variety of techniques. It's not just to chop, but you can hook lens pieces up out of the bag. So you can see this is a white cataract. I'll use a corneal marker, which will help me to center and size the rexus. This patient, obviously this is a right eye. This patient has a Bell's reflex, again, looking up, which is towards the left side of the screen. I control the eye so I can get a good paracentesis incision, make sure it's flat to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine, and then some intracameral epinephrine. And then I'm going to put a little air bubble in the eye, and this is a trypan blue. Again, I don't want to overfill the eye with trypan blue and risk getting that trypan in the back of the eye. You see this patient has a little bit of a shallow chamber, and so even though I'm putting the dye in, the chamber is collapsing. Go ahead and inject some dispersive viscoelastic to fill the anterior chamber, flatten the anterior capsule, and coat the cornea. I'm using the cannula to hold the eye, and this is a triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel through the cornea, turn the eye towards me with the cannula, and then I enter. Again, using the cannula gives me great control of the length of my incision. Now, this is a little bit of an intumescent lens, so I'm going to take a 27 gauge needle, and I'm going to puncture the center, and then I'm going to aspirate. So puncture the center, quickly aspirate, and the idea being you want to get rid of that cortical milk that's in the eye. So that milky material is what's intumescent and what can cause that anterior capsule split, the so-called Argentinian flag. So these are sharp tip haldiperical forceps. Of course, there's already a tear. I'm going to start going around circumferentially, and thankfully there's not a whole lot of milk coming out now. I have very good control with these low-profile capsulorhexis forceps. Of course, the trypan blue really helps me see what I'm doing here with this white cataract. I'm approaching the subincisional area, but no problem. I have great view, great chamber stability. Finish off the rexus. Now, this is the capsular fornix hydrodissection technique. I place a cannula under the rexus edge contra-incisionally. In these cases, the lens is already pretty much disassociated from the capsular bag. So this is really a formality, to be honest with you. But I go ahead and sweep and push fluid on both sides. You saw the lens began to spin here. So pretty dense lens, white cataract. Again, not a tiny pupil, but not a huge pupil, kind of a middle-sized pupil. Lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma, removing the surface epinuclear material, having the chopper pronated in my hand, leading off with the chopper tip, getting under the rexus edge, getting and hooking the peripheral lens, tilting the phakic tip vertically subincisionally, bringing the instruments together very slowly and carefully. It fractures the lens completely in half. You can see it's through and through. Placing the chopper underneath the rexus edge around the right heminucleus, pulling it centrally toward the phakic tip, and it fractures the right heminucleus. Using some vacuum to lift that first quadrant up, and then fracturing it in half, and then grabbing one of those fragments up with some vacuum, and then crushing it into smaller and smaller pieces, and then emulsifying the lens piece. So let's see that one more time. Again, I'm leading off with the chopper tip, pronating my hand, making it flat, a flat approach, removing the surface epinuclear material. And once I've done that, I'm going to push down on the surface, making sure I'm under the rexus edge, rotating the chopper vertically now. It's around the lens equator, rotating the phakic tip vertically subincisionally. You can feel the density of the lens between the instruments. And then when you know you have it in good position, you're holding it well, you can bring the instruments together and it fractures it. And you can feel that you're completely around the lens when you do this. Again, it's one of those things, until you do it, you really don't understand what that means. So once you have the instruments around it, you're able to fracture it. Again, no vacuum, no ultrasonic energy, just purely under irrigation fluid. And you just position the instruments and then fracture it. Same thing here, you place a chopper on the right heminucleus, pulling it centrally toward the phaco tip. In this case, the chopper is cutting, but then the phaco tip is acting like a chopping block. And so it doesn't move, it stays right there. And as the chopper is brought towards the center, it fractures that right heminucleus. I'm getting around that first quadrant. And again, doing the same cross chop maneuver, fracturing that first quadrant in half, and then grabbing that fragment with some vacuum, lifting it up, and then crushing it into smaller pieces, and then emulsifying the lens piece. Just very carefully, systematically, just crushing the lens into smaller and smaller pieces, and then emulsifying the lens piece. Sometimes it's hard to just lift stuff out of the bag because the lens is so dense, it's kind of jigsawed together. And that's how you leverage using the chopper to help hook lens pieces up and popping the lens pieces up out of the bag. So that first quadrant is essentially out now. I place the chopper around the second quadrant, pulling it central toward the phaco tip, holding the, you see the phaco tip is even sideways. It doesn't have to be directly on. And you're just using the side of the phaco tip as a chopping block. And so you're just able to fracture the lens. So again, using multiple successive crushing maneuvers, making the pieces smaller, and then more effectively emulsifying the lens pieces and utilizing less ultrasonic energy in the process. Rotating the lens a little bit towards me, counterclockwise, that remainder of that second quadrant, using some vacuum to grab that piece. I decided to just kind of leave that piece there. I'm going after the second heminucleus, placing the chopper around the lens piece, placing the phaco tip deep in the bag, fracturing the lens completely in half, going after that third quadrant, getting around the lens equator, pulling it centrally toward the phaco tip. Again, the phaco tip's acting like a chopping block, and it fractures the lens in half. Using some vacuum to grab that fragment, crushing it between the instruments, and doing that again and again, and then emulsifying the lens piece. Again, you try to get that chopper around the lens, hugging the lens from the other side, and then fracturing it, bringing the instruments together, crushing it between the instruments, and then emulsifying the lens piece. So again, some people think it looks chaotic because there's a lot going on, but as long as you're focused on just crushing and crushing and crushing the pieces into smaller and smaller pieces, then you can go ahead and activate vacuum and ultrasonic energy, and then all the pieces will start coming out. And I like doing it this way because it makes sure that all the pieces are right there in front of me, less likely to kind of fly out of the way and go underneath, the iris or something like that. Again, minimizing ultrasonic energy and vacuum with lens disassembly. I'm rotating that lens piece in front of me, again, placing the chopper around it, getting around the lens equator, fracturing it, pulling it centrally toward the phaco tip. Again, the phaco tip is acting like a chopping block, and it fractures the lens. Amputating that deep adhesion between the two lenses, the scissoring chop maneuver. Once I amputate that deep adhesion, now it's completely disengaged from the other piece of the lens. Using crushing forces to crush the lens into smaller and smaller pieces, and then eventually emulsifying the lens piece. This is the last quadrant. You can see it's fairly loose now. I'll place the chopper around the lens, trying to position, you see what I'm doing that, I'm just trying to position the lens and position the instruments around the lens piece, and then fracturing it. And that's the beauty of this. You're doing, really, this is all just under irrigation, and you have all the luxury of trying to just carefully position the instruments around the lens and then fracturing it. You don't have to try to lollipop it. You don't have to sculpt it. You don't have to do any of these things that is kind of, ultrasound-driven techniques. And so that's kind of the concept. Ultrasound-driven techniques are what, the traditional techniques are, but this is not an ultrasound-driven technique. You use it to emulsify the lens on the back end. But disassembling of the lens is not really dependent upon that. You're using mechanical forces. This is a mechanical fracturing driven technique. So you crush the lens pieces into smaller and smaller pieces, and then emulsifying the lens piece. Because you're just using manual forces, you can have an eye filled with OVD and irrigation fluid, and again, very controllably fracture the lens with different vector forces, different angles, And you don't have to worry about rotating the lens within the bag because you're able to disassemble the lens from so many different ways. To me, this is really another key advantage of doing cataract surgery this way. You don't have to depend upon rotating the lens within the bag. So I take the chopper out, push BSS in, take the phaco tip out, and I go in with the INA handpiece. You can see that that was a pretty dense lens, but now it's gone. And not much cortex left, but there is some. So I start to go after the cortical material. And then I quickly switch to polish mode because, again, most of that cortex is pretty much gone. And I want to make sure I get underneath the anterior capsule, removing all the lens epithelial cells. You saw I grabbed a little bit of cortex, switched to cortex mode, grabbed that piece, and then switch back to polish mode quickly there. So again, that's a beautiful part of having foot pedal control, being able to move to each successive step, going back and forth. And so you are literally at the driver's seat, being able to control the different modes throughout the case. So I'm polishing underneath in the subincisional capsule fornix. You see this big chunk of cortex comes out. So I switch to cortex mode and get rid of that. I go back with the cannula, again, pulsing into the subincisional capsule fornix. I switch to the cohesive viscoelastic, filling the capsular bag, and then making sure I polish under the rexus edge. Polishing on the left side and then the right side. Removing the lens epithelial cells. Again, there's not a huge pupil. It's not a tiny pupil, kind of a medium-ish pupil. But again, pretty dense cataract, 3 to 4 plus, white cataract. Thankfully, it wasn't too intumescent. And in this case, I'm going to go with a single piece acrylic lens. It's going to go into the capsular bag. I employed, using trypan blue, painting the anterior capsule surface. Again, punctured the center with the needle and then aspirating for any milk. Luckily, that wasn't that much. And then I used the sharp tip, low profile Haldane-Perkar forceps. Great control doing the rexus with these forceps. And then again, showing lens disassembly techniques. So again, I get underneath the lens, tilting it, rotating it, removing the viscoelastic from within the bag. I'll polish underneath the rexus edge as well, and then removing the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, 3 to 4 plus dense lens, taking advantage of mechanical fracturing principles, getting the instruments around the lens on both sides. You saw in that case, there's no moving of the lens transitionally. I'm not really ripping zonules, even if it tilts, but it didn't in this case. There's really no tilting. I was able to have great control, hugging the lens from either side, fracturing it with the instruments. Again, not utilizing any ultrasonic energy or vacuum during that maneuver. Why? Because this is why it's called double chop. I'm using the phaco tip like a chopper, so it doesn't need to use ultrasonic energy or vacuum in those steps. Disassembling the lens very confidently with cross-chop maneuvers, being able to crush it and disassemble the lens in a variety of vector angles. And that's why this is so versatile. I'm able to just use mechanical fracturing forces to disassemble the lens. I'm utilizing less ultrasonic energy and vacuum as a result. And this patient, even though their CDE was 4.51, it's certainly not in double digits. And as a result, this patient had really clear cornea post-op day one. This was a white cataract. You can imagine how ecstatic this patient was, going from essentially blind with this dense white cataract and being able to see literally the next day. Even actually later that day, he had excellent vision. So you can see I have a PanOptix lens in this eye, and I'm asking the patient to look at the light, making sure that the lens is well-centered. And so this is very important in order to make sure you get a really well-centered lens for these types of lenses. And the patient had great vision, distance and near, without glasses, with this trifocal lens implant, the PanOptix lens. So I hope this was helpful to you, and I thank you for your attention.